Section 8.2 gets into hypothesis testing in a little bit more detail. So we're actually going to go through the steps and look at how we would conduct a hypothesis test. So there's 4 general steps you want to be familiar with. The first is what we did in class today, and that's to hypothesize. So the first thing you want to do is come up with your null hypothesis and your alternative hypothesis. Next, you want to, I call this the prepare step, and what I mean by that is state your significance level. If they don't give you one, just use 5%. We'll do an example in a minute. Choose an appropriate test statistic, check any conditions if necessary, and then just kind of get ready to run your test. And then the next thing is compute. So that's where you actually put the information into StatCrunch. You're going to compute the observed value for your test statistic, and then find the p-value that goes with that. And then finally, we're going to interpret. So based on the p-value that you get in step 3, are you going to reject or fail to reject the null hypothesis? And what does this mean for your conclusion? So the conditions you need to check are actually the same as they were in Chapter 7. There's 3 conditions that have to apply because we're still using the central limit theorem. The first is that the sample has to be random and independent. As long as it's a simple random sample or they tell you that the sample was done randomly, we're good to go there. It has to be large enough to expect at least 10 successes and 10 failures. And the way we're going to check that, so the number of successes would be n times p naught. And then, of course, the number of failures would be n times 1 minus p naught. And then the population has to be at least 10 times the sample size, so 10 times larger than the sample size. Let's take a look at an example. In 2009, it was estimated that 63% of Americans supported the death penalty. So what are we saying? Previously in 2009, we think that the population proportion who supported the death penalty was 63%. In 2014, we conducted a poll and we found that a random sample of 943 Americans, 538 supported the death penalty. Does this give us evidence that the support of the death penalty has declined among Americans since 2009? So let's start with the null and the alternative hypothesis. So the null hypothesis, remember, is the assumption that nothing has changed, status quo, it is still 63%. So the population proportion is still 63%. Notice I'm using p here, not p hat. The alternative then, remember, is always based on the way the question is phrased. So it says, do we have evidence that the support for the death penalty has declined? So that would be that p is now less than 63%. Is this a one-sided or a two-sided hypothesis test? Well, if it's less than or greater than, that means it's a one-sided test. Is it left or right? So think about if it's less than, you're going to shade to the left. Check the conditions. Is the sample random? Yes, they told us it was a random sample. Is it large enough? I'm going to skip actually checking the details for this, but yes, as long as you've got 943, that's certainly large enough for at least 10 successes and 10 failures. And is the population at least 10 times larger than the sample? Of course, we're talking about the population of all Americans, so that would certainly be large enough. Often a level of significance is given, but if they don't give you a level of significance, then just default to the most common one, which is 5%. And by the way, the symbol for the significance level is alpha. So alpha, remember, is always going to be your significance level. And the significance level is what we're going to use to check that p-value. Remember, we talked a little bit today in class about whether or not the p-value was small or not small. And the way we check that is by comparing it to the significance level. So just default to 5% for that if they don't give you one. So what year is representing the sample in this situation? Well, 2014 was the year that we have the Rasmussen poll. So 2014 would be the year that represented the sample. Therefore, the values in 2009 are considered parameters, while the values in 2014 are considered statistics. Okay, just a little refresher that statistics go with samples, parameters go with populations. All right, it says compute the test statistic. Now, the test statistic, remember, is another name for your z-score. And so if you'll recall, the z-score formula we used was p hat minus p naught divided by the standard error. Before I get too involved here, I need to compute the standard error. So remember the standard error, we're going to use p naught times 1 minus p naught divided by n all under the radical. So that's going to give us a p naught value. So our p naught value is what went with our hypothesis, and that would be 63%. So I've got 0.63 times 1 minus 0.63 over n. My sample size, I didn't jot it down, but my sample size was 943, so that's going to be my n value. And more decimals are better here. We noticed today in class there are a few situations where we did not get accurate answers with StatCrunch because we were cutting off the decimals too soon. So when you do your standard error, I would say a minimum of 4 decimals. If you're getting weird values, maybe just try 5 decimals. It's not going to hurt to use more decimals for your standard error. And then at the end, you'll round it to however they tell you to round it in StatCrunch. So based on what I've got here, I've got looks like 0.157. I'm just going to go with 4 for now. So 0.157 is my standard error. Now, I still need to get p hat. I haven't computed p hat. So remember, p hat is your sample proportion. So for me, that would be the 538 out of the 943. So let's figure that out. So 548 divided by 943. And I'm just going to use the calculator sitting next to me instead of the one on the computer. Well, it's acting funny. Let me go back to the computer. So 548 divided by 943, I'm getting a sample portion of about 58%. So let's do 0.58. All right, so then my test statistic is going to be 0.58 minus P naught. Remember, P naught was the 63%, divided by the standard error that I just computed. All right, so let's go back to the calculator here. And let's see, I'm going to use my calculator by hand. 0.58 minus 0.63 divided by 0.0157. And I'm getting a test statistic of negative 3.18. Now, the fact that it's negative should make sense because my sample proportion was lower than my hypothesis proportion, my population parameter. So remember, when that's lower, that means it's on the left if we graph it. So I should get a negative z-score. We know, so what does this mean? This means we are 3.18 standard errors below the expected proportion of 63%. We know it is very unusual to be 3.18 standard errors below the mean. And so the mean, remember, was the 0.63 in this case. In practice, we would use StatCrunch to calculate the test statistic and find the p-value. So what are the steps for doing this in StatCrunch? It's actually the same steps we used for confidence interval. If you remember last week when you opened up the window in StatCrunch to go to the confidence interval, one of the options was hypothesis testing. It's the same procedure. You're just going to click on hypothesis test instead of confidence interval. So I think I have a window open somewhere here. Here it is. So, let me log into StatCrunch. And let's just run through it real quick so you can see what this looks like. All right, so we're going to go to stats, proportion stats, one sample with summary. My number of successes was the 548 out of the number of observations, which is 943. Now we're going to run a hypothesis test. Now, one thing you do need to do is put in the hypotheses. So my P was equal to 0.63. My alternative was that P was less than 0.63. It's very important that this matches what you have for your hypotheses or your P-value is not going to be the right one. So I'm going to click on compute, and this is the information we need. So there's my hypotheses. My sample proportion is 58%. My standard error I calculated earlier by hand, but there it is again, 0.0157. Same thing with my z-score. And again, you notice the rounding really makes a difference. When I rounded, I had a z-score of negative 3.18. The way they've rounded it, they're probably using more decimals. They've got a slightly different z-score. In the end, it doesn't matter. They're both really extreme values, and it's not going to affect the p-value because the decimals are a little bit off, but it might affect your answer in my stat lab. So just keep that in mind. More decimals are always better. The p-value that goes with this, though, is 0.0009. So let's put some of this into our notes here. All right, so we've got, let's see. So here's what your screenshot looks like from StatCrunch. So they reiterate what your hypotheses are. P equals 0.63. My alternative was that P was less than 0.63. I had 548 out of 943, I think was what it was. My sample proportion was 0.58 something something. My standard error was 0.0157 something something. My Z-score was negative 3.10 from StatCrunch, and my p-value that went with it was 0.0009. So it says label the normal distribution below with the test statistics and shade the appropriate area representing the p-value. So what you want to remember, this is really important that you remember this, your p-value is your probability. Your p-value is the shaded area in the graph. If the null hypothesis were true, it's the likelihood of getting our particular sample. So here's what this would look like. In the middle would go my expected value. That was the 63%. My sample proportion was actually 58%. That was my p hat. So 58% is going to go somewhere over here. Since my alternative hypothesis, so let's write that up here just as a reminder, my alternative hypothesis was less than, what that means is when I graph this, my p-value is the area to the curve of the curve that's to the left of my test statistic. Now, a couple things to note. I'm using 0.63 and 0.58. If I wrote this as a z distribution, this would be 0, and this would be a test statistic of negative 3.10, because remember, that was my z-score, right? And actually, I should have put this 0.58 much further out towards the end, the tail, right? Because negative 3 standard errors should have been way further out. But we'll go with the picture that I have. So the p-value, though, that we got from StatCrunch is what's shaded right here. So that's the 0.0009. So what does this mean in the context of the example? So the p-value is the probability. Let's write that down. So that is the probability of getting a sample with 58% or less. Why is it or less? Because of this less than right here. That's the reason. So it's probably getting a sample with 58% or less if the population proportion is still at 63%. So another way of saying that is if H naught is still true, if the null hypothesis is still true, the likelihood of getting our particular sample of 58% or something smaller is 0.0009. Now, what do you think about that? What do you think about that probability? Is that a high probability? No, that's a really small number. That's less than 1% chance. So think of it in like a larger context. What we're saying is the likelihood of getting this particular sample, if the population proportion is still 63%, is so small, it's not even 1% chance that we would get this particular sample. So what that does is that gives us evidence to reject the null hypothesis. So let's write some things down. Our p-value is 0.0009. And what you can remember is that that is less than our significance level. Remember, our significance level was 0.05. That's quite a bit less than 0.05. So anything below 5% usually gives us strong evidence to reject the null hypothesis. So small p-values mean that we're going to reject the null hypothesis, is what that means. So would you reject or fail to reject? Well, yes, we just said that. We're going to reject the null hypothesis. So let's summarize what this means. So if we reject the null hypothesis, we reject H naught, what this means is that, let's say this sample gives evidence to support the alternative hypothesis, H sub A. What was the alternative hypothesis? That the population proportion who supports the death penalty, right? Wasn't it the death penalty? Has likely declined. So the real population proportion, even though in 2009 it was 63%, it's probably not 63% anymore. That's what we're saying. Okay? We think it actually probably has declined, and that's based on our alternative hypothesis, which said that we want to know if the population proportion has declined below 63%. All right, calculation of the p-value depends on the symbol in the alternative hypothesis. Remember that if the alternative hypothesis contains a not equal to, we say that the alternative hypothesis is two-sided. I sometimes say two-tailed when I'm talking about these. And the p-value would be the total shaded regions shown below. So like, let's say I'm just going to put p naught here, whatever p naught is. And then let's say my p hat value is over here. If it's a two-tailed test, so like if h sub a would look like this, p does not equal p naught, whatever that number is. That means I would have something over here, and then I would also have something over here. And I'm using p, I could also use z-scores as well. So we could also, if we were using z-scores, we'd have a 0 here, and then we would have a positive z-score here and a negative z-score here. So when you have a two-tailed test, your p-value that gets computed by StatCrunch is going to be the sum of this tail plus this tail, okay? If you've got less than or equal to, we have a one-tailed test or a one-sided test. So if it's less than, that means we have a left-sided test, and the p-value is the area to the left of the test statistic. So let's do it using z-scores. Let's put 0 here, and then if that's the case, if I'm doing h sub a is that p is less than p naught, then my test statistic that I get, it could be over here. It could be on this side as well. You could end up with a really large p-value. It depends on what you're working with. But like, let's say I've got something over here, and I've got a test statistic on this side. It would be negative if I'm over here. The tail that I'm looking at, the p-value, would be this tail right here, the area of this tail right here. I could also have something over here, and it would be a really large p-value. But the point is, you're shading to the left. That's the important thing. If we've got greater than, that means we have a right-sided test, and the p-value shaded is to the right. So if my z is here, or my 0 is here, then my z would probably be on this side somewhere, but it could also be a negative z-score, and I could still shade to the right. That just would be a very large p-value, but it is possible. And then my p-value would be this area over here. Here, we'll label this one as well. So my p-value up here would be this area, okay? Let's do another example. According to Times Magazine, the dropout rate for all college students in 2012, so this is pretty old data, with students with loans was 30%. Has the current dropout rate changed? Suppose that 65 out of 200 randomly selected college students with loans drops out. So the null hypothesis would be that P equals, nothing has changed, P is still 30%. The alternative hypothesis would be that P, since it says, let's see, college students with loans, has this dropout rate changed? We're going to say not equal to 30%. Is this one-sided or two-sided? So since it's not equal to, we know it's two-sided. The results of the test given in the TI-84 graphing calculator are shown below. Why are there two tails? Okay, so this is what we talked about earlier. Why are there two tails? Since the alternative hypothesis is a two-sided test, right? So since it's not equal to, that's why we're going to have those two tails, those two shaded areas. The test statistic is given to me here in the screenshot, so that z equals is my test statistic. So z equals 0.7715. I'm just getting it from the screen right there. And then also, the other thing, and this is a little confusing, I know there's a lot of P's floating around, but when you see a screenshot like this in StatCrunch or in, this is from a graphing calculator, they said, this P right here, this is your P value. I know it's confusing, but that P that they're computing, that's the area of these two tails. So our P value in this particular example is 0.4404. Does this P value give us strong evidence to reject the null hypothesis? Well, what do you think? This P value is quite large. It's 44%. Remember, our cutoff, if they don't give us one, is 5%. But regardless, this is still a very large P value. So that means that no, we would fail to reject the null hypothesis because the P value is quite large. It's 44%. P value is large. Is there evidence then to reject that the dropout rate for all college students with loans is 30%? No, we're not going to reject that. No. So this means the evidence from our sample shows that the dropout rate has not changed from the 30%. So we still think the dropout rate is probably around 30%. We haven't changed. We don't have enough evidence to indicate that it's changed based on this particular sample that we have. So we fail to reject the null hypothesis in that case. All right, let's try this one. For each graph below, indicate whether the shaded area could represent a p-value. The first one would certainly be yes, right? This would be a two-sided test because the two tails are shaded. This one would be no, since the tails are not shaded. And that's all they want you to look at there. Let's try another example. It says, suppose a poll of 250 randomly selected voters in a city found that 140 of them favored increased funding for public libraries. Based on this poll, could we conclude that a majority of voters, so a majority meaning more than 50%, favor increased funding for public libraries? This time now they're telling us to use a significance level of 0.01. So let's get our hypotheses first. So the null hypothesis, when you have a majority test like this, your null hypothesis is just that P equals 50%. So for majority tests, just go with that. P equals 50%. That's what we're going to assume. Our alternative then is what we're trying to test, and that's the majority, that P is greater than 50%. Again, I'm going to kind of skip the details here, but as long as they told us it was a random sample, which they did, 140 is certainly large enough, and our population is all people in the city or all voters in the city, so that would certainly be large enough as well. All right, let's compare or compute to compare. So I'm going to go ahead. Let's go to StatCrunch and put this data into StatCrunch directly. So let me pull up StatCrunch again, and I'm actually going to go here and go to Options Edit, and I can just change my information. So they told us that we had 250 people that we selected. 140 favored increased funding. So 140 out of 250. So I'm going to change my hypotheses to P equals 50% for the null hypothesis and that P is greater than 50% for the alternative. We're going to click on compute, and here's the information I need. So let's go back to our notes. Let's put some of this information in here. And so we've got my alternative, or my null was that P was equal to 50%. My alternative was that P was greater than 50%. I had 140 out of 250. My sample proportion, let's go to StatCrunch. What was that? My sample proportion was 0.56. And my standard error, again, notice StatCrunch computed that for me. It was 0.0316. So 0.0316, and my z-score was 1.9, we'll say. So my z-score was 1.90, and then the associated p-value with that is 0.0289. So 0.0289. Let's make a quick sketch of what this would have looked like. So here's my distribution. Let's use z-scores to do this. I'm going to put 0 in the middle. My z-score was 1.9, which was right here. Which way would I shade? Because it was a right-sided test, right? Greater than. I'm going to shade to the right. So the p-value that StatCrunch gave me, this 0.0289 number, that represents the shaded area. So what does that tell us? Now, here's where that significance level really matters. We were given a significance level of alpha equals 0.01. That was given to us in the question. There are some scenarios where a significance level needs to be smaller, like in medical research, for example. They tend to use smaller significance levels because they really want to be sure about their results. In business, they might use a 10% significance level because they're able to take a little bit more risk in something like that. But depending on what it is, they might give you different significant levels. In this question, for whatever reason, they wanted us to use a 1% significance level. So that is the number I need to compare our p-value to, is to the 1% now, not the 5% we were using earlier, since they specified that. So our p-value, 0.0289, this time it is larger, right? Our p-value is larger than our significance level. It's about 2.8%. So it's larger than our significance level. So we will fail to reject the null hypothesis. That means we think the null hypothesis is probably true. We don't have enough evidence to support the alternative. So since we fail to reject the null hypothesis, we do not have evidence. We do not have evidence that a majority, right? Because our alternative hypothesis was that a majority, we do not have evidence that a majority support increased funding for libraries. So this gives us a way to kind of measure the pulse of what we think is happening. We think that based on this sample, there is not enough support. We don't have a majority support for increased funding for libraries based on this sample. Let's do one more here. A group of medical researchers knew from previous studies that in the past, about 39% of all men between the ages of 45 and 59 were regularly active. So I'm going to stop right there. I'm going to write something down because that's going to be our null hypothesis. So our null hypothesis, our population parameter, is that P is equal to 39%. Okay? The researchers were concerned that this percentage has declined. So that means my alternative hypothesis is decline means lower than. So that means my alternative is that P is less than 39% now. We've dropped below that number. For this reason, they selected a random sample without replacement of 1,927 men in this age group and interviewed them. Out of the sample, 680 said they were regularly active. So let's figure out what that is. So that means P hat is going to be 680 out of 1927, and we'll get that percentage in a minute. Decide whether the proportion of regularly active men in this age group has declined, and they want us to use a 5% significance level. So let's compute my P hat value. So my P hat value is 680 divided by 1927. And actually, I'm going to put this in StatCrunch, so it's about 35%. But StatCrunch is going to do the work for me here. So let's go to StatCrunch and let's put in our information. I'm going to go to Options, Edit here, and we'll just start over with a new sample. So it was 680 out of 1927, right? I believe that's what it was, wasn't it? Sorry, I forgot the number. It was 680, yeah. 680 out of 1927. All right, so my null hypothesis was that P was still 39%. My alternative is that P is less than 39%. So we're going to click Compute, and here's my information. So my sample proportion, there's the 35% I said it was a minute ago. My standard error is provided. My z-score is negative 3.34. Even without looking at the p-value, even if I didn't give you the p-value, if I just gave you the z-score, that's actually good enough to answer the question, because you should see that this z-score is very extreme. Any z-scores outside of 2 standard errors are going to be considered very extreme or unusual z-scores, and they're going to be associated with a very small p-value. So my p-value, let's write that down. Our z-score was negative 3.34. All right, negative 3.34. And the p-value associated with that is 0.0004. So the p-value is 0.0004. Okay, so what the heck does this mean? What does this mean? Well, is this a small p-value compared to our 5% significance level? Yes, that p-value is certainly less than our alpha of 5%. That's very small. So when the p is small, you will reject the null hypothesis. So since the p-value is small, smaller than the significance level, we will reject the null hypothesis. What does that mean? The null hypothesis was that p was still 39%. So this gives us evidence in support of the alternative. So we have evidence to support that the population proportion who exercise, or whatever it was, who are active, has done what? Has declined or dropped from the 39% that we think it once was. So this sample gives us evidence to support that there actually has been a decline in the population because we had that small p-value.